You know, we've all done it. We've said something like, that car's speed is 60 miles an hour heading north. But what if I told you that's technically not right? Yeah, in the world of physics, speed and velocity are two totally different things. And today, we're going to unpack exactly why that little difference matters so much.
So let's just get right to the heart of it. Why on earth do we even need two separate words for what feels like the same exact concept? I mean, it seems kind of redundant, doesn't it? Well, as it turns out, there's a really powerful reason, and it's a concept that lets us describe the world with amazing precision.
And here it is. The entire key to unlocking this whole puzzle comes down to just two words: scalars and vectors. Seriously, once you get what these two things are, the whole speed versus velocity thing just clicks into place. It becomes totally clear.
Okay, so first up, scalar quantities. The simplest way to think about a scalar is that it's just a number. That's it. It tells you how much of something there is, its size or magnitude, but that's all you get. It's pure information about quantity with no extra context.
Now let's bring in the vector. A vector also tells you how much. It has a magnitude, just like a scalar. But then it adds one absolutely crucial, game-changing piece of information: direction. So it's not just a random number anymore. It's a number with a purpose. It's pointing somewhere.
Let's make this real. Imagine a plane flying. If we just say it's flying at 250 meters per second, that's its speed. That's a scalar. But the moment we say it's flying 250 meters per second to the east, well, now we're talking about its velocity. That's a vector. It's all about adding that direction.
Okay, so before we jump right back to speed and velocity, let's take this new scalar versus vector idea for a test drive. We can use it on another pair of words that people mix up all the time: distance and displacement. Think of this as the perfect warm-up.
So in this pair, distance is our scalar. It's simply the total amount of ground you covered. You walked 40 meters? Great, your distance is 40 meters. Simple. But displacement, that's our vector. It doesn't just care how far you walked. It cares about your change in position from your starting point to your ending point. So 40 meters east isn't your distance, it's your displacement.
All right, warm-up's over. We've got our tools ready. We know the difference between scalars and vectors. So let's circle back and tackle the main event: speed versus velocity. To make this as clear as possible, let's set up a little scene. Picture a train, and it's crossing a bridge. We measure the bridge, and it's exactly 550 meters long. Now that 550 meters, that's our distance.
And let's say we get out a stopwatch and time the train. It takes precisely 10 seconds to get from one side of that bridge to the other. So now we have our two key ingredients: distance and time. We're ready to do a little math.
So, to get the train's speed, we use a really easy formula. Speed equals distance divided by time. All we have to do is plug in our numbers. We take our scalar distance, 550 meters, and divide it by 10 seconds. And that gives us a speed of 55 meters per second. But notice, there's no direction. It's just a number. That's what makes it a scalar. Okay, now watch this, because this is where it all comes together. We're going to do almost the exact same calculation, but we're just going to add one tiny little piece to the puzzle: direction. And you're going to see how it changes everything. All right, this time we're told the train was traveling east. So instead of a distance of 550 meters, we now have a displacement of 550 meters east. When we take that vector and divide it by time, guess what we get? We get another vector, 55 meters per second east. That's our velocity. See, it's the same number, but it's a completely different kind of measurement because of that one word: east.
And hey, just a quick little heads up here, because physics formulas can be a bit quirky. You'll often see the letter S in these equations. The tricky part is, in the speed equation, S can stand for speed, but in the velocity one, S often stands for displacement. I know, a little confusing, right? It's just one of those things you kind of have to file away for later.
And this is where using velocity gets really powerful. You can actually have a negative velocity. So what does that mean? It's simple. It just means you're going in the opposite direction. A velocity of, say, negative 55 meters per second just means you're moving at 55 meters per second, but you're going backward. It's a really elegant and simple way to describe motion. So we've been throwing this number around, 55 meters per second. But let's be honest, what does that actually feel like? Let's try to ground these ideas with some real-world examples so we can get a better feel for these speeds. Okay, take a look at this. You can really see the massive differences here. A pretty casual walk is about 1.5 meters per second. A car just cruising along is way up there at 25. And then, wow, look at that jump to a plane. We're talking 250 meters per second, maybe even more. It really helps put things in perspective.
And just to fill in a few more of the gaps, a decent running pace is around 3 meters per second. If you're on a bike, you can probably double that to about 6. So our train at 55 meters per second? Yeah, that's legitimately fast. But if you want to see something truly mind-blowing, look at the speed of sound, a whopping 330 meters per second.
So if there's just one thing you take away from all of this, let it be this. Speed is how fast. Velocity is how fast and in which direction. That's it. That one little piece of information, the direction, is like a compass that turns a simple number into a precise story about motion.
And that brings me to a final thought, one that goes a little beyond physics. This whole idea that just adding a direction can completely change the meaning of something, well, that applies to so much more than trains and planes. So think about it. Where else in life does having a clear direction, a which way, totally transform the meaning of an effort